So tired. So many videos. Well, we gotta do another one. How many do we have left? Just one? You promise, this is the last one. All right, let's do this. Welcome back to Unit 12. Today we're going to be talking about measurement, and we're going to be specifically talking about surface area of rectangular prisms and cylinders. A fun fact that if you've been watching these videos from Unit 1 till now, this is the last video in Math 7 that you need to watch. Sure, of course, you can always go back and review those videos, but this is the last one in the series. So let's go ahead and get started with it, talking about surface area of rectangular prisms. So first we need some summary of calculations. So you can see there that that doesn't look much like a rectangular prism. I've taken my shape and I've broken it down and unfolded it. And when we unfold something like that, we call it a net. So rectangular prism that can be represented on a flat surface, so taking a 3D shape and making a 2D shape, is making something called a net. So our net here has have the measures of the length and width. Two of our rectangles have the measure of length and height. Two of our rectangles have the measure of width and height. And when we're talking about that, the surface area of the rectangular prism is the sum, or the answer to an addition problem, of all the areas of the 6 faces. So we're going to take our 6 faces, we're going to add them together, and that's how we find our surface area. So let's go ahead and do that now. We'll move to the cylinder here in a second, but we're going to find the surface area, or the areas of all of our rectangles. So remember, our area formula for a rectangle is length times width. So we're going to be doing that for all of our rectangles. So 7 times 3 there, that's going to give us 21. 7 times 3, that's going to give us 21. So those are our 2 rectangles there that measure that. 3 times 10 is going to give me 30. 3 times 10 is going to give me 30. Then our last one is 7 times 10 is going to give me 70. 7 times 10 is going to give me 70. So in order to find the area, we're going to just add those all up. So we're going to add our 21s together. That's going to give me 42. So we're going to add those together. Then we're going to take our 2 30s and we're going to add those together. That's going to give me 60. Then we're going to add our 2 70s together, and that's going to give me 140. So now that I've had all those numbers together, the 140 plus 60 is going to give me 200. 200 plus 42 is going to give me 242. So our surface area is going to be 242 by just adding all of them together. And since we're talking about measurement here, we need to have a measurement of feet in this case. And since we're talking about surface area, we're talking about 2 dimensions, our length and our width. That's going to be a squared. So anytime that we're talking about surface area, we need to throw a squared on there. So that is how we calculate that. Now let's move on to our cylinder. So again, I took my cylinder and I flattened it out and I laid it down so that it is a net. And a cylinder contains, or represented on a flat surface, or a net, of 2 circles, okay, and we call those the base of the cylinder. Then we have 1 rectangle whose region length is going to be the circumference of the circular base. So it's going to go around the base, and whose width is the height of the cylinder. The surface area of the cylinder is going to be the sum of the area of the 2 circles and the rectangle. And that makes sense. We're going to find the area of the top, find the area of the bottom, find the area all the way around the sides, and then we're going to add those together, and that's going to give us our total area. So let's start with our circles. So we know our area formula for circle is going to be pi r squared, as we've talked about before. So now we know that pi, every time that we're going to use pi, we're going to represent using 3.14. Yes, we know it goes on forever, but we need some sort of common base number for all of us to use for standardized test and testing class and classworks, etc. And our radius is going to be 3 squared. Now we need to use our order of operations here. So we're going to do our exponent first. So 3 squared is going to be 9. So then we're going to multiply our 9 times our 3.14. And when we do that, we're going to get 28.26. So we know that's going to be the area of one of our circles, but we've got 2 circles, so we're going to have to make sure that when we go to add them together at the end that we've got 2 circles there. So we've got 28.26 for this circle, 28.26 for this circle. So now all we need to do is find the area of our rectangle, and we know that's going to be length times width. So length times width, I know our length is going to be, what is our length going to be? Well, I'm not quite sure, but I know my width is going to be 8. That's labeled right here on the side, so I know my width is going to be 8. In order to find the length, I have to remember that my shape is going to, or the rectangle is going to be shaped around or turned around a circle around the top of my of my cylinder. So since it's going to go around the top, I need to know how far it is from one side of the cylinder to the other. And in that case, it's going to be 6 because my radius is 3. My diameter will be 6, so my length is 6. So my area is going to be 6 times 8. So 6 times 8, I know what that is. I can figure that out to be 48. So now that I've got my area of both things, I can add them together. So I need to remember that I'm going to be adding 28.26 for one circle, 28.26 for the other circle, and then 48 for the length of my rectangle, length and width of my rectangle. So I'm going to add those together. And when I do that, I'm going to end up with an answer of 104.2. So my surface area is going to be 104.52. And again, I need to have a label as this problem talks about measurement. So again, I'm talking about meters in this particular problem, so it's going to be meters squared. Now let's take a look at a few applications and our specific formulas when it comes to surface area. So when we're talking about surface area, we want to be using formulas. We don't want to take every 3D shape that we're given, try and lay it out in a 2D shape, and then apply the formula by multiplying every single rectangle or multiplying some circles and trying to figure out what the length is every time. So to do that, or help us out with that, we've got a surface area formula for cylinder and a surface area formula for rectangle. So now that we know where their formulas came from, we can use our formulas so that we don't have to make the work harder on ourselves. So now let's take a look at our applications of surface area, so things that would be applicable to using surface area on. So again, when we're talking around the outside of a shape. So filling a can with soup, no, that is not going to be surface area because you're going to be filling it up. However, painting a box or covering it around the outside with paint will be surface area. Wrapping a present will be surface area, okay, as we cover our present with wrapping paper. Putting ice cream in a cone, sorry to say, that is going to be volume as we fill it up. Painting a room, however, will be surface area as we cover that room with paint. Filling the pool, not so much. Pouring water in a glass, not so much, but covering the box around the outside, yes, that's going to apply to surface area. So now that we can have applications of surface area, we've got a few examples down there at the bottom. So example A says Sarah wants to make a soup can that is 7 centimeters wide, 11 centimeters tall. How much aluminum does she need to make this can? So this problem lends itself to using our formula for this. So our surface area formula for our cylinder, since we know it's going to be a soup can, which is going to be cylinder shaped, is going to be 2 pi r squared for our two circles, plus 2 pi RH to figure out our rectangular portion. So now we need to plug in the information that we have from our formula. So we know that our 2 is going to be 2. Our pi is going to be 3.14. Our radius, it tells us, is going to be 7 centimeters wide. So we need to figure out what our radius is since it's going all the way across at 7. So we need to know that what half of that is. So 7 divided by 2 is going to be 3.5. So that's going to be our radius squared. Plus 2 times pi, which we said is 3.14. Plus our radius, which we know is 3.5, times our height, which is going to be 11. So now that we've got all of our information, we need to do each side of the formula first separately before adding them together, because remember, we need to follow the order of operations. So we're going to be doing all of our multiplication first before we add the two sides. So let's start with our left-hand side, and we're going to again need to do our exponents first. So 3.5 squared is going to be 12.25. So then we're going to multiply that times our 2 times our 3.14, and when we do that, we end up with 76.93 for one side of our formula. Now we need to do the other side of our formula. So again, we're going to do our 2 times 3.14 times our radius, which is 3.5 times 11, and when we do that, we get 241.78. So that's the other side of our formula. So now we're going to add those two numbers together to give us our final answer. So we're going to add the 241.78 plus our 76.93, and we're going to get our surface area of equaling 318.71. And again, this is measurement, so we need to have our centimeters, and so we're talking about surface area, it needs to be squared. Now again, remember, it's very important that we do each side of the formula separately before adding them together. Because adding them together, our calculator doesn't always necessarily know the order of operations like we do. So we need to make sure we're doing all of our multiplication first, and then all of our other multiplication, and then adding them together. So now let's take a look at example B, and it says Danny is wrapping this present. How many square inches of wrapping paper does he need to cover this box? So again, we're going to grab our rectangular prism formula from up there at the top, so we can see that that's going to be surface area is equal to 2 lengths times width plus 2 lengths times height plus 2 widths times height. So now we're going to be plugging our information in that we have as we go along. So we know what our 2 is going to be. We know our length is going to be 15. Our width is 5. Then we need to plug that in as add that to 2 times our length, which we just said was 15, times our height, which is going to be 7. And then finally, we need to add that to 2 times our width, which is 5, times our height, which is 7. And again, we need to follow our order of operations. So we're going to be needing to do our multiplication first. So we're going to have to do our 2 times 15 times 5. Then we're going to have to do our 2 times 15 times 7. And finally, we're going to have to do our 2 times 5 times 7 so that we have our information separated before we add. So 2 times 15 times 5 is our first one. So 2 times 15 times 5 in our calculator is going to give us 150. We're going to be adding that to our 2 times 15 times 7, which is going to be 210. And then we're going to be adding that to our 2 times 5 times 7, which is going to be 70. So when we add those all together, our surface area is going to be 430, and again, it's a measurement, so we need to have our inches squared. Now looking at example C, it says Mino is painting the outside of the cylinder. How many square inches of space will he cover? Round to the nearest hundredth of an inch. I'm going to let you try this one on your own. So using the formula that we've given you up above, we had the radius, so you don't need to figure out that separate from a diameter. So I want you to use the formula, plug it in, do the best that you can, and then press play again to see if you are right. How did you do? Did you end up getting the same answer that I did? Hopefully you made the rounding correct. If you got 211.008, remember you need to round to the nearest hundredth, so that was going to make that 0 go up to a 1, so you should end up with 211.01. Then remember, we need to throw a measurement on that, so since we're talking about inches, we're going to be having our inches, and we're going to be talking about squared. That brings us to the end of this video and the end of this series. If you like both those things, go ahead and throw us a thumbs up. If you love this video, go ahead and throw us a sub, and we will catch you in the next one.